Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the zeolite process, which is also known as permitted process. Zeolite process is highly useful for the removal of permanent hardness from the water. So coming to the zeolite, it can be defined as hydrated sodium aluminum silicate. So zeolite can be defined as hydrated sodium aluminum silicate. So chemically it can be written as Na2O Al2O3 X SiO2 and YH2O. Here the value of X varies from 2 to 10, whereas the value of Y varies from 2 to 6. So zeolite can be chemically represented as Na2O Al2O3 X SiO2 and YH2O. So especially with respect to zeolite, the sodium ions are highly active. So whenever the hard water is passed through the zeolite bed, it is capable of exchanging its sodium ions with hardness producing cations, in particular calcium and magnesium ions. So simply the sodium zeolite can be represented as Na2Ze. So coming to the process of zeolite, initially the zeolite bed is taken in a cylinder. So zeolite bed is fitted in a cylinder. So especially this cylinder is fitted with the zeolite bed, which is highly porous in nature. Always it is supported with a gravel layer. The treated water, that means the soft water, can be removed from this outlet. So from this outlet it is possible to collect the soft water. At the top it is provided with the inlet for the hard water. It is the inlet for the hard water. So whenever the hard water is passed through the zeolite bed, it is capable of exchanging its sodium ions with calcium and magnesium ions present in the hard water. And always remember one fact, it removes only cations from the hard water and it leaves the acidic groups chloride, bicarbonate and sulfate as such in the treated water. So this zeolite process is highly useful for the removal of hardness producing cations, and it is not useful for the removal of acidic groups from the hard water. And always the treated water contains more number of sodium salts. If at all any sludge is formed, that can be removed through this outlet. After some time, if all the sodium ions present in the zeolite bed are being replaced by the calcium and magnesium ions, then the zeolite bed is called exhausted zeolite bed. So it will not contain any sodium ions. Then at this moment also, when hard water is passed, it is incapable of removing hardness producing cations from the water. So at this moment, stop the passage of the hard water, and this zeolite bed can be regenerated by using brine solution. So whenever the zeolite bed is exhausted, just stop the passage of hard water, and always here the brine solution is passed through the zeolite bed. Brine solution means it is nothing but 10% NaCl solution. So it contains sodium ions, and hence this zeolite bed can regain its sodium ions, and after some time now this regenerated zeolite bed is ready to remove again calcium and magnesium ions present in the hard water. So by using brine solution, it is possible to regenerate the exhausted zeolite bed. It is the total process of zeolite. Let us consider what are the chemical reactions that takes place whenever hard water is passed through the zeolite bed. So in particular, zeolite bed can be represented as Na2Ze. So it is capable of removing both calcium and magnesium ions responsible for the hardness. Let us see how it reacts with calcium bicarbonate. Here, whenever hard water containing calcium bicarbonate is passed through the zeolite bed, it just exchanges its sodium ions with the calcium ions present in the water. Then it results in the formation of calcium zeolite and sodium bicarbonate solution. In a similar way, it is also capable of exchanging its sodium ions with the magnesium ions present in the water. Let us consider magnesium chloride. So in this case also, it replaces its sodium ions with magnesium ion, and that results in the formation of magnesium zeolite along with the formation of NaCl. So whenever the hard water is passed through the zeolite bed, then it results in the formation of calcium zeolite and magnesium zeolite. And here what are the byproducts formed? Sodium salts will be formed as the byproducts. So the treated water contains more number of sodium ions. So after some time, if all the sodium ions present in the zeolite bed are being replaced by the calcium and magnesium ions present in the hard water, then it is called as exhausted zeolite bed, and it is incapable of removing calcium and magnesium ions present in the hard water. So at this moment, stop the supply of hard water, and this zeolite bed, especially the exhausted zeolite bed, can be regenerated by washing with brine solution. So coming to the regeneration of exhausted zeolite bed, it can be done by washing with 10% NaCl solution, that is called as brine solution. So let us see how the exhausted zeolite bed can be regenerated by washing with 10% NaCl solution. Let us consider calcium zeolite. When it is treated with NaCl solution, automatically the calcium ions present in the calcium zeolite bed are being replaced by the sodium ions, and it results in the formation of sodium zeolite. In the similar way, the magnesium zeolite is also capable of exchanging its magnesium ions with the sodium ions, and thus it results in the formation of sodium zeolite along with the formation of magnesium chloride. So in this way, the exhausted zeolite bed can be regenerated by washing with 10% NaCl solution. And always remember one fact: the exhausted zeolite bed will not contain sodium ions. So in general, the zeolite bed contains sodium ions, aluminum ions, and silica ions, whereas the zeolite bed will not contain sodium ions. So coming to the advantages of this zeolite process. Zeolite process is highly useful for the removal of permanent hardness, and thus it removes hardness up to 10 ppm. At the same time, the equipment is compact and hence it occupies very small place. The maintenance is easy and less skill is required. Coming to the disadvantages of this zeolite process, especially the treated water contains more amounts of sodium salts than lime soda process. Especially this method is useful for the removal of only calcium and magnesium ions. So it can replace only calcium and magnesium ions and leaves especially the acidic ions such as chloride, bicarbonate and sulfate unaffected. This zeolite bed being porous in nature, that's why the turbidity of water should be less than 10 ppm. Zeolite bed is porous and hence turbidity of the water should be less than 10 ppm. Then only the hardness can be removed. And whenever the acidic water is used, it destroys the zeolite bed. So acidic water destroys zeolite bed. So zeolite process is not suitable for the acidulated water. So these are the few disadvantages associated with the zeolite process. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.